right, 7th grade. The work that I gave you on Monday or either Tuesday, depending on what day that you come in. I am right now in Miss Sid's class. Everybody say hello. You're on video. Hello. All right. We're going to do number 3 first. Number 3, we're talking about prediction, okay? Jennifer and Carl select letter tiles based on the letters in their names. They place the letters inside of a bag. So basically they took Jennifer, Jenn, they toss it in a bag. That's where these letters came from. If Luis selects one letter from the bag 2 times without replacing them, what is the probability that he will select a vowel both times? So when you are doing probability, go ahead and write down what you want, okay? And also, the word of a vowel may be new to you. A vowel is A, E, I, O, or U. So in other words, this is the favorable, okay? So the probability of pulling a vowel and pulling a vowel again, okay? So what is the probability of pulling a vowel? 1, 2, 3, 4. And how many tiles do I have in here? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, if you know, if both the numerator and the denominator are even, I can reduce it. But I also notice that there's a greatest common factor of 4. So if I divide, 4 divided by 4 will give me 1. 12 divided by 4 will give me 3. These numbers are a lot easier when I'm working with them. Okay, but going back, I'm going to use this in a second. I'm going to go back up to my probability of a vowel, which is 4 out of 12. But when I pulled, remember that without replacing. That means that it is dependent. The second event is dependent on the first event. So think about it. I pull one of those vowels out. It is no longer in there. And that is the key word right here, is without. Okay? So how many vowels do I now have? 1, 2, 3. It changes the numerator here, or the number of vowels, but it also changes the total possible outcomes. Now I only have 11, okay? When we have 2 events in a probability problem, there's always one mathematical operation that we're going to do. That's right, we are going to multiply, okay? Now, I simplified this one. I know I'm going to multiply the 2 ratios. Can I simplify 3 11ths anymore? No, because 11 is a prime number. So 3 over 11. So my answer is going to be top times top. I do not add when you multiply fractions. You always multiply your top times your top, bottom times bottom. So my probability, and I can even reduce this, 3, if I divide the numerator and the denominator by 3, gives me 1 over 11. So really what that means is if I were to do the experiment 11 times, if I were to theoretically, every one time out of every 11 trials of going into the bag, pulling out a vowel and another vowel would be 1 out of 11. Okay? All right, let's look at number 4. I'm looking at my time, sorry. Okay, so we basically have, I don't know how many, an 8-sided dice, octagon. If he wants to conduct an experiment where he rolls an 8-sided number cube labeled 1 through 8, and then rolls a 10-sided number cube labeled 1 through 10, if he repeats the experiment 240 times, what is the probability that he will land on 5 when he rolls the 8-sided cube and land on 9 when he rolls the 10-sided cube? How many times should he expect to land on both numbers? Okay, so first what we need to do is find the theoretical probability. Okay, so what is the I'm going to work out of what is the probability of rolling? Okay, so we have 2 experiments. I'll come back to the 240. I want to roll a 5. So what is the probability? This is 8 sides. And this was 10 sides. Okay, and the favorable is a 5 and a 9. And the way we write that is the probability of rolling a 5 and then rolling a 9 on my 10-sided dice. So how do I, when I have 2 events, and when I roll the 10-sided dice does not affect what happens on the 8-sided dice. So the probability of rolling a 5 would be, it happens 1 time. I don't put a 5 on top. You have to look at how many times does the 5 appear. And then your denominator will always be the total number of sides, which is 8. So my chances of rolling that 5, it only appears 1 time, is 1 out of 8. Now let's look at the 10-sided dice. I know, yeah, that's right. Okay, you're going to put a 10 on the bottom, and how many times does that appear? 1 time. So the hard part about dice is that we want to put that number on top, but you have to look at the frequency. How many times does it appear? And we know that when you have 2 events, you always multiply. So top times top is 1. I don't add. And then 8 times 10 is 80. So if I theoretically were to roll the first die, roll the second, for me to get a 5 and then a 9, it will happen 1 out of 80 trials. That's the theoretical probability. So what I'm going to do, if I repeat the experiment 240 times, so predictions happen, obviously. With predictions, we use a tic-tac-toe. The favorable was 1 out of 80, right? And I want to know, if I were to spin it, or if I were to do the experiment 240 times, how many times would it happen? That's right. Now you multiply 240 times 1 and divide it by the number across from your x. So 240 divided by 80. And I know that 24 divided by 8 is 3, but I'm working with a 0, so it would happen 30 times. Nope, my bad. Yes. No. What am I thinking? I am so sorry. 240. Miss Kowalski is having a brain freeze. 80 does not go into 240 3 times. 80, I know that 24 divided by 8 is 3, but because I'm working in tens, it only goes in 3 times. Okay, I am so sorry. Miss Kowalski had a late night. So 3 times 80 is 240. Yes, it went in evenly. And I don't want to redo that video. All right, guys. So it is already 8 minutes in. I just wanted to go over. I will do one more video on some of the back ones, but I'm going to have to do it in a separate video, okay? I'll see you in a second.